Welcome back. This is an Aleks training video on counting valence electrons in an atomic ion. Now in a previous video we've looked at counting valence electrons in a neutral atom. It's just equal to the column that it's in. If it's in a representative element, say 1 through 8, then whatever column it's in, that's the number of valence electrons. An ion changes the number of electrons. So if an ion changes the number of electrons, you're going to have to either go left or right from where a neutral atom would be, and then whatever column you're in, that would be the number of electrons. So look at a periodic table, please. Here is your example. How many valence electrons are in a carbon +1 ion? So it's a carbon ion, carbon cation. Well, if I've got a +1, do I have more electrons than normal or less electrons than normal? I have less electrons than normal. How many? If I have a +1, I'm missing 1 electron. So I can't be, carbon is in group 4, 4A, it's in the representative elements 4 column, which means there's 4 valence electrons. But if I'm missing an electron, if I'm a +1, I'm short 1 electron, then I don't have the valence electrons of 4 because I'm 1 less electron than I need to have 4. So I have to go left to the 3rd column. Okay, that would be the boron column. Boron and aluminum, gallium column all have 3, but a C+, a carbon cation, carbon 1 cation, is short 1 electron, so you go to the left one, and it would have the same valence electrons as the previous column. So it, in this case, is going to have 3 valence electrons. So 3 valence electrons in carbon plus. So what you do is you find out how many electrons do you have more than normal if you have a negative anion, and you go to the right, that number. If you have less, then you go to the left, that number. If you have, let's say, 3 less, you have 3 less, but you've run out of columns. As you're going left, you run out of columns. You're going to have to go to the previous column, number 8. So you just kind of keep going back and forth on the periodic table, left and right, and the valence electrons is going to be that column. Okay, I hope that's okay.